Okay, good morning. We continue our lesson with a new topic, which is actually very important and ubiquitous in mathematics, and that's the notion of the absolute value. Of course, the lesson is very simple, but sometimes it becomes technical. So my goal is to start very slowly so that we can get used to this notion and then try to solve harder problems in the level, of course, of the book. Uh, so what do we mean by absolute value? So let x be a real number, positive, negative, or zero, of course. The absolute value, or sometimes called modulus of x, is denoted by this symbol and is defined as follows. So we say that absolute value of x is equal to x itself if x is greater than 0, is equal to 0 if x itself is equal to 0, or it is equal to negative of x if x is negative. So in principle, one way to talk about the absolute value of a number is say that the absolute value of any real number is its magnitude, regardless of its sign, positiveness or negativeness. How much number is there? How much value is there in a number? That is called the absolute value, okay, of that number. But what I want you to understand today is the definition, is a rigorous definition of absolute value here. So the reason that this is important, because absolute values are actually ubiquitous in mathematics. You see them more or less in every context of mathematics. But usually whenever you want to do something which is related to absolute value, the first thing that you need to do is to get rid of absolute value sign. To get rid of absolute value sign, you need to invoke this definition here. Okay. So let me just solve one example for you here so that we get familiar to it. So example number 1. Write each of the following expressions without using the absolute value sign. Okay, so here you see number 1, I have absolute value of 2. Okay, can I get rid of the absolute value sign? Yes, because I need to go and look inside the absolute value sign and check if it is certainly positive, 0, or negative. When I look inside this absolute value, I see number 2, and I know this number 2 for sure is positive. So according to the definition, what I'm supposed to do is just simply remove the absolute value. So here I would say that absolute value of 2 is equal to 2. If someone asks me why, I would say that because 2 is certainly a positive number. Okay, now let us go to number 2. Can I remove the absolute value here? Again, the answer is yes, because what happens now? When I go and look inside the absolute value sign, I see the whole expression here, and that is minus 2, and we know for sure minus 2 is a negative number. So, can I remove this absolute value sign? Yes, but the price that I have to pay, you see, if x is negative, you can't get rid of this absolute value sign, but there is a price that you have to pay, and that is to multiply whatever is inside the absolute value sign by a negative sign. Okay? Please listen, you might think that I am exaggerating, defining this a little bit. At this stage it might be true, but if you are patient you will see why I am emphasizing so much on this way of thinking. So if I want to solve that problem, I remove the pair of absolute value signs, these parallel lines, and then because minus 2 is negative, I myself multiply it by a negative, extra negative sign, and the answer becomes 2. Of course, in the future, I want you to be able to tell me immediately the answer without going through this intermediate step, but I want you to also understand the definition. Okay, so number 3. Absolute value of 0, here it is defined. If x is equal to 0, absolute value of 0 is defined to be 0 itself. So nothing. So absolute value of 0 is equal to 0. And number 4. So let me write number 4 here. Again, I want to get rid of this absolute value sign. I look inside the absolute value sign, I see this number. I need to ask myself, is it positive or negative for sure? It's clear that the square root of 2 is smaller than the square root of 3, so this difference is definitely a negative number. Can I remove the pair of absolute value signs? The answer is yes, but the price that I have to pay according to the definition is to multiply the whole package inside the absolute value sign by a negative number. So what happens if I want to solve it from scratch? So I would have a square root of 2 minus a square root of 3 in absolute value sign. I remove the pair of absolute value signs here, but the price that I have is to pay it by a negative sign. So if I multiply the first number by a negative sign, it becomes minus the square root of 2. The second number is already negative, so it turns out to be a positive number. So that is the answer to this, which I prefer to write square root of 3 minus the square root of 2. So the answer of this is actually this. Okay, let us go to number 5. In number 5, you see you are facing with a variable x, and you don't know anything about x. So in principle, x could be 0, it could be negative or positive. Yes? But the point is that the whole package that I see in the absolute value sign is always non-negative, even if x itself is negative, because I am raising a number to power 2, so it cannot be negative even if I put a negative value for x. Okay, so number 5, even though I don't know what the value of x is, but I would say that absolute value of x squared is equal to x squared itself. Okay? What about number 6? Here, the package inside the absolute value is read minus x to the 4. Yes? X can be any number, positive, negative, or 0, but when I raise it to power 4, definitely because 4 is an even number, it becomes non-negative. But then at the end, I am multiplying it by a negative sign. So if I ask you, are you certain about the sign of this expression, even though you cannot be certain of the sign of x, you would say yes. Because of this reasoning, we know that this expression is definitely non-positive. Okay, so it means that can I remove the pair of absolute value signs? Yes, but the price that I have to pay is to multiply the package by a negative sign. Yes, so number 6, if I want to solve that, it becomes minus x4. I remove the pair of brackets, the pair of absolute value signs, but because this is negative, I multiply it by a negative sign. The answer would be x to the power of 4. Okay, what about number 7? So the number 7 is also the same thing. You see here, I have some number inside the absolute value sign, but this expression consists of two variables, x and y, and in principle x and y could be positive, negative, 0, or a combination of them. So we have different possibilities, but it doesn't matter here because whatever x is to the power of even 4 is even. So this package is non-negative. When I multiply it by minus 2, this expression becomes non-positive. Okay, and the same is true for this one. So that package is also non-positive. Now I am adding two non-positive numbers, so definitely the answer would be non-positive. So I am certain about the sign of the whole package to be negative, even though I am not certain about the sign of x and y individually. Yeah? Okay. So what I do, I will write it in this form. So I would say that minus 2x to the 4 minus 3y squared is equal to, I remove the absolute value sign, but because I realize that it is always a non-positive number, the price that I have to pay is to multiply it by a negative sign, and when I apply this minus sign in the pair of brackets, it becomes 2x to the 4 plus 3y squared. Yes? Okay, finally number 8. Number 8, I don't know the value for x. x might be larger than 2, then the whole expression becomes negative. X might be equal to 2, then the whole package becomes 0. And it might be less than 2, and then 2 minus x becomes positive. So it is not clear. We cannot be sure. We are not certain about the sign of this expression inside the pair of absolute value signs. So in principle, either I am not allowed to remove it, but if I insist to remove it, which sometimes we have to, then I have to discuss. Then I would say that absolute value of 2 minus x is equal to there are three possibilities. It becomes 2 minus x if x is less than 2. Why? Because if x is less than 2, now it is guaranteed that this expression is positive, so I can simply get rid of absolute value signs and write 2 minus x. It becomes equal to 0 if x is equal to 2. Why? Because if x is equal to 2, 2 minus 2 becomes 0, and absolute value 0 is equal to 0. Another situation is that x is greater than 2. What happens? Yes, when x is greater than 2, 2 minus that number becomes negative. Can I still remove the pair of absolute value signs? The answer is yes, but I have to multiply it by a negative sign. So if I insist to get rid of absolute value sign in this case, I have to write it in a more elaborate way, So this is why actually we use absolute value signs in mathematics. Instead of writing so many things here, we just simply write compactly absolute value of 2 minus x, and if you are a mathematician and you know about the rules, you immediately can translate this whenever necessary yourself. Yes? Okay, so that's it, and of course I prefer to multiply that negative sign in, so 2 minus x, x less than 2, 0, x is equal to 2, and if I multiply that negative sign inside, it becomes x minus 2 if x is greater than 2. Okay, so still I want you to really exercise on this definition. Let me talk a little bit about the remark. So what is geometrical interpretation? Okay, this is a different remark, sorry. So here in this example we learn that inside the absolute value sign we can have all possibilities regarding the sign of that expression. That might be a positive number, might be a negative number, might be 0. But you see, in all cases the output is non-negative. It means that the output might be 0 if the input is 0, but the output is always positive regardless of if the input is positive or negative. So inside the absolute value sign you can put any number that you like with any sign that you like, but the output is either 0 or greater than 0. The output cannot be negative. So that is something that I want you to know. Okay. This is the content of actually this remark here for you. There is also another remark that I want to talk about, and it's also very, very important, and that is the geometric interpretation of the absolute value. For example, let us consider a number, a real number a, whatever it is, and then let us talk about geometrical interpretation of the absolute value of a. So you know that to any number you can associate a point on the x-axis. So for example, if you have an x-axis here, you know that you have x-axis and some point of it is called the origin of the x-axis, and then because this is a geometrical object, yes, this is a geometrical object, this is not a number, this is a shape, this is a axis, yes, and so it consists of infinitely many points, yes? But we know how to associate real numbers with the points on the x-axis. For example, 0, which is a real number, is associated to the origin, yes? If I talk about number 1, it means that I go 1 unit to the right, I get a point. That point is is associated to number 1. So usually we write 1 here. For example, this point is associated with number 2. And if I go to the opposite direction, this point is associated with -1. I don't know, this one is associated with -4. And even square root of 2, for example, is associated with exactly one single point. By the way, I forgot to mention this uniqueness. For any number, you can find a unique point on the x-axis that you can associate it with that. Okay, but of course, for the case of a square root of 2, it might be harder to find. I don't want to deviate that much. For example, you can use Pythagoras theorem. Go 1 unit to the right, 1 unit up. Then this is 1 unit, this is 1 unit. According to the Pythagoras theorem, this is a square root of 2. And then you put the needle of the compass here and open the compass here, and then you just draw a arc so that it will intersect the x-axis at a point. That point is associated with the square root of 2. But of course, I don't want you to I don't want to distract you with these details. But what I want to emphasize is that you know that any real number is associated with one single point on the x-axis. And then what is the meaning of the absolute value of that number? It is the distance from the point corresponding to that number on the x-axis to the origin. For example, if you say absolute value of 2, it means that you can go and find the point corresponding to 2, which is this point, and then measure this distance. This distance, whatever it is a square absolute value of 2. And of course, it is reasonable. If I ask you what is the distance of this point to the origin, you would say 2. What is absolute value of 2? You would say 2. For example, if I ask you what is the geometric interpretation of absolute value of -2, you will go and find -2. -2 is here. The distance that you measure from this point to the origin is absolute value of -2. And that is again true, because if I ask you what is the distance from this point to that point, you don't say -2, you say the distance is 2. And that is reasonable here as well, because absolute value of -2 will learn that it is equal to 2. Okay? So if someone asks you what is the geometrical interpretation of absolute value of a number, you would say that if I go to the x-axis, there is one point, and exactly one point on the x-axis which corresponds to that real number. I take my ruler and measure the distance from that point on the x-axis to the origin of the x-axis. Whatever I get is the absolute value of that number from geometrical point of view. Another thing that is also very important, I want you to understand what is the geometric interpretation of absolute value of the difference of two numbers. The absolute value of a minus b, what is that? So let me draw a diagram here for you. So if I have the x-axis, and this is for example O, I have two numbers a and b, but of course these numbers can have different have different signs. For example, let me consider this point is a and this point is b. Okay? Of course, in this case I have considered both of them positive, and I have considered that a is smaller than b. If I measure this distance is absolute value of a minus b. So absolute value of a minus b, as I have written here, is the distance between the points on the x-axis that correspond to a and b. So that is the meaning of the absolute value of the difference of two numbers. For example, let me ask you what is this one? So what is the geometric interpretation of absolute value of -2 minus 3? Yes. Okay, if you compare this one with this one, minus 2 is playing the role of A, and 3 is playing the role of B. According to what I just said, absolute value of minus 2 minus 3 is the distance between the point that corresponds to minus 2 and the point that corresponds to 3 on the x-axis. Okay, so for example, on this x-axis that you see, let me find minus 2. Where is minus 2? Minus 2 is here. And let me find 3. 1, 2, 3. So 3 is here. If I ask you what is the distance between these two, you really don't need to measure anything. This is very elementary. What is the distance? 1 unit, 2, 3, 4, and 5. So the distance between this point and this point is actually 5. But now let me calculate my absolute value of minus 2, minus 3 here for you. If I ask you to calculate this, you have to calculate this one first. It's minus 2 minus 3, which is minus 5. And the answer becomes absolute value of minus 5. But we learned that absolute value of minus 5 is minus 5, and that is exactly 5. So you immediately realize that if I calculate using algebra, I get the same number if I measure it using geometry. Okay? So it's extremely important to understand that. And then I have immediately asked you one question here. A and B are real numbers. What is the geometric interpretation of the absolute value of A plus B? You see, this is extremely important. If you want to interpret this as a distance, this would be a negative sign. This has to be a negative sign. But here I have a positive sign. But I don't think that's a big problem, is it? Because instead of A plus B, I can imagine it as A. Instead of plus, I want to have it minus. But I cannot just write minus unless I compensate for that minus by another minus sign. So hopefully you agree with me, there is no difference between this and this one. Why? Because minus minus b is the same b. But now you see that I have one number a, I have another number minus b, and the sign between them is minus sign. So I would say that this is, so therefore absolute value of a plus b is the distance between the points on the x-axis that correspond to A and minus B. Okay, so that's also good to know. So whenever you want to interpret the distance between 2 points as an absolute value, the sign between them should be negative. If it is negative, you can immediately interpret it as a distance between 2 points A and B, but that's positive, you need to use this trick to change it to the negative sign. Okay, now let us go to the next example, which is actually a very important example. Important doesn't necessarily mean hard. Okay, so here consider an expression. I call this absolute value expression to be A, and I'm asking you write A without absolute value sign if x is a real number such that x lies between -1 and 2. Okay, so the point is clear. I want to write expression A without the absolute value sign, but we learned so far that I will not be able to get rid of the absolute value sign unless I am certain about the sign of the expression inside the absolute value sign. And here this condition will help me to decide about the sign of this expression, the sign of this expression, and the sign of this expression, so that in principle I should be able to remove the absolute value sign. So for example, what can I do? You can just actually convince yourself if x is a number between -1 and 2, it is clear that if I add 2 units to such an x, then I will definitely get a positive number. If I want to write it rigorously, I would say that you are telling me that x is somewhere between minus 1 and 2, so I can add 2 units to everything, so it becomes 2 plus minus 1, which is 1, is less than x plus 2 is less than 4. Because you are telling me that x is between minus 1 and 2, I myself realize that x plus 2 is somewhere between 1 and 4. And of course, when x plus 2 is somewhere between 1 and 4, definitely x plus 2 is positive. And when x plus 2 is positive, I can immediately conclude that the absolute value of that expression is equal to the expression itself. Okay? Let us do it one more time for the second term. You are telling me that x is between minus 1 and 3. Okay, I want to infer something about x minus 3, so it motivates me to subtract minus 3 from every side of this inequality. So minus 1 minus 3 becomes minus 4, x minus 3 becomes x minus 3, and oh, sorry, I made a mistake in writing this here. This is not 3, this is 2. So this is 2, and then this becomes minus 1. Okay, so let me just, I started from here. This motivates me to subtract minus 3 from every side of this, so I just did that one, I get this one. X minus 3 is a number that is between minus 4 and minus 1. So definitely in this case, x minus 3 is negative. And when it's negative, absolute value of x minus 3, can I remove the pair of absolute value sign here? The answer is yes, but the price that I have to pay is to multiply it by a negative sign. And then if I multiply negative by negative 3, it becomes positive 3, and then I will have minus x. And finally, I want to say something about 5 minus 2x. So x is between minus 1 and 2. Now I want to construct 5 minus 2x. So the first thing comes to mind is to multiply everything by minus 2 because I want to make minus 2x here. But remember from the previous studies, if I multiply an inequality by a negative number, I have to flip the signs. So negative 1 times negative 2 is positive 2, but I have to flip the sign, negative 2x, and then I have to flip the sign, negative 2 times 2 is negative 4. But you see that I have an extra 5 here. So I want to make this 5 minus 2x. So what should I do? I need to add 5 to every side. So it becomes 5 plus 2, 7, less than 5 minus 2x, less than 5 minus 4 is 1. Oh, sorry, again, I made a mistake here. I have to keep the signs in that direction. For me, it is easier to read it the other way around. This tells you 7 is greater than this. This is greater than 1. Equivalently, this means that this number that I am interested in is somewhere between 1 and 7. I don't care about where does it lie. I care about is it positive or negative. But of course then it becomes clear that 5 minus 2x is positive. And then this means that absolute value of 5 minus 2x is equal to itself. Okay? So therefore, the a that I am looking for is equal to, here I have a 2. Absolute value of x plus 2 is equal to x plus 2. Be careful, some people might write it in this way. This is not correct. 2 is multiplied by the whole expression, so I have to put a pair of brackets around. And I have minus 4. Absolute value of x minus 3. Absolute value of x minus 3 is 3 minus x. So it becomes 3 minus x. And then I have minus sign here. And then I realize absolute value of 5 minus 2x is equal to 5 minus 2x itself. But I don't forget to put pair of brackets. Now I open it and simplify it. So it becomes 2x plus 4 minus 12 plus 4x minus 5 plus 2x. And if you simplify that, so here 4x, 2x is 6x, 2x is 8x. So I will have 8x and then here I have 4 minus 12 is minus 8, minus 8 minus 5 is minus 13. Yes, so it becomes minus 13. So what I get is actually a simplified version of this expression. So we were able to write this expression without any absolute value signs. Okay? Now let us go to another example. So here, this is a multiple choice question. We know a, b, and x are real numbers, but we also have this extra piece of information regarding these numbers. 0 is less than a is less than b is less than x. We want to write this expression. The expression is then equal to which one? Of course, by looking immediately at the options, you realize that we have to get rid of the absolute value because none of them contains any absolute value sign. But can I do that? The answer is very simple and yes, because for example, by looking at this, let me write the first one here. So you see that all three numbers are positive. So x is positive, b is positive, and I am adding them, so it becomes positive, yes? So x plus b is definitely a positive number by this condition, so this implies that x absolute value of this is equal to itself. But what about the other one, b minus a minus x? We have to be a little bit more careful here. Okay, so b minus a minus x, I would write it in this way. I would write it as b minus x together and then minus a. And now let me see if it is positive or negative. Why I did this? Because I am completely sure that this is negative. Why? Because I see that b is smaller than x. And I have the b minus x, so this is negative. But a itself is positive. Minus sign added to that, it becomes negative. So this part is negative, this part is negative, and I am adding them, so it becomes a negative number at the end. So definitely this becomes negative. And then what does it mean? It means that absolute value of b minus a minus x is negative of that expression. But then if I multiply the negative sign in, negative x becomes positive x, negative a becomes positive a, and positive b becomes negative b. So the expression in question is equal to, instead of the first one, I put this, and instead of the second one, I put this. Yes? So what happens? It becomes x plus a minus b, and then plus x plus b. And then you see that this b and that b are cancelled, so what you get is 2x plus a. And 2x plus a is actually the second option. Yes? Let us go to the next problem. Let a, b be real numbers. We have two conditions on them. We know that b is negative, but a is positive because this tells you that 0 is between b and a. And this tells you that the absolute value of a is greater than the absolute value of b. Yes, so it means that, so if I want to feel it, I would say that a is positive, b is negative. But from numerical point of view, from magnitude point of view, a, the positive one, is more powerful. Yes, because its absolute value is greater than the absolute value of the negative one. So it means that if I want to, by the way, that's good to understand it, even though it is not part of this problem. It means that if I want to understand it from geometrical point of view, which is also interesting, it means that here, for example, is the origin. B is somewhere on the left hand side here, and A is somewhere on the right hand side. But, for example, is this the correct way to put B here and A here? No. Because the second condition tells you that the distance from A to the origin absolute value of A, is greater than the distance from B to the origin. If I draw it in this picture, I am just not respecting this. You see, this is larger than this one. So the second condition tells me that wherever you want to put B on the left, put it, but you have to respect that A should be farther away from the origin. So this is a reasonable picture, yes? Because this would be then, this distance is absolute value of B, and this distance is absolute value of A, and then you can see that at least in my diagram I have respected this condition. So if you want to draw a picture, that's a good thing to remember. Okay, now the expression that I am looking for is this. It consists of three absolute values. So let us start with these one. You know that A is positive. This is given in the problem. So what can I conclude about absolute value of A? This becomes A itself. It's also given in the problem that B is negative. So what can I conclude about absolute value B? I can write it as minus B. Okay? But what is A plus B? Is it positive or negative? Be careful. If this condition was not given to me, I was not able to determine for sure the sign of A plus B. Because in that case, if I don't have this, what I know is that A is positive and B is negative. In this case, you see the positive one is more powerful than the negative one. So when I add, the positive one will dominate and this becomes positive. Oh, if A is here and B is there, then the negative one will dominate and this becomes negative. So if this condition was not there, I was not able to, for sure, I was not able to determine the sign of it certainly. So this is why now, by this analogy that I just told you here, A plus B, hopefully you agree with me, is again positive. Because from magnitude point of view, this negative number is smaller than this positive number. So when I add them, the positive one will dominate and then it becomes positive. So then it means that the absolute value of A plus B is equal to A plus B. So the question mark is equal to. Instead of this expression, I can write A plus B. Instead of this expression, I can put A. And instead of the last one, I can put minus B. So it becomes plus minus B. And then simply this one and that one are gone, and I will get 2A. So the answer to this problem is the third option. Yes? Okay. Now let us solve the last problem for today. Let A and B be non-zero real numbers with opposite signs. So we don't know which one is positive, which one is negative, but we know that one of them is positive, the other one is definitely negative. Simplify the following expression as much as possible. So that's a tricky question. It's a nice question, I would say. It's much simpler than it looks like. Okay, so we know that A and B have opposite signs. For example, we don't know which one is which. Let us start two cases. We have two scenarios going on. Either A is positive and B is negative. This is one case. Another case is that A is negative and B is positive. Okay, so let us consider case number one. Okay, case number one. You tell me that A is positive, so what I can conclude is that absolute value of A is equal to A itself. So this means that if I divide A by its absolute value, it becomes 1. Yes? If A is positive. If now B is negative, because if A is positive, B has to be negative. Okay, when B is negative, what can I conclude? I can conclude that absolute value of B is negative B. So then it means that if I divide B by absolute value of B, this becomes B. Instead of absolute value of B, I put minus B. And then if I simplify this, it becomes negative 1. Okay, so let me just write. In this case, we realize that this number is 1 and this number is minus 1. Yes, this is in this case. Of course, let me just immediately speak about the second scenario. If a is negative, then this becomes negative 1, this becomes positive 1. So one of them becomes negative 1, the other one becomes positive 1. But the good point is that when I add them, it becomes 0. In both cases. Here, in this case, the first one is 1, the second one is minus 1. So when I add them, it becomes 0, and because that's a product, who cares about what is here? This I don't know, but we don't need to know, because this part is 0, 0 times the question mark is 0. If I am facing the second scenario, then this one becomes minus 1, this becomes 1, but when I add them, again the answer is 0. And then who cares about what the value of this one is, but the answer becomes again 0. So this means that, therefore, a over absolute value of a plus b over absolute value of b is equal to 0, and then this means that the question mark is also equal to 0 in both cases, of course. Okay, so again, be careful. For example, if I ask you, can you tell me the value of this? The value of this is also clear, so let me change the color. This part is not part of the solution. But you can also understand that because you are saying that a and b are opposite, are numbers with opposite signs. So this means that the product is negative because one of them is positive, the other one is negative. And then this means that the absolute value of AB is negative of AB. So then this means that A over B, AB over absolute value of A over B is again minus 1. So if I asked you, is this also calculable? Yes, calculable. So you would say that yes. The answer is minus 1. But if I ask you, can you tell me what the value of this one is? Then you don't know. Because one of them is positive, the other one is negative. If I have a positive number and a negative number, if I add them, it might be negative or might be positive. It depends to the power, which one dominates. The positive one dominates or the negative one dominates. But one thing is clear. Whatever this expression is, a plus b, let me also write it here. A plus b divided by absolute value of a plus b is either 1 or minus 1. But we don't know. Because if I want to make sure which one is this, I need to know more about A and B. I need to know which one will dominate in this sum. Okay? Okay, so I think here is a good stopping point for stop. And then I will continue the absolute value sign on the next session. Okay, thank you very much.